All right, friends and neighbors, welcome back to another networking video. We are continuing our series on home networking and what's on my home network. And so today we're going to talk about home Ethernet. I have lots of show and tell for you, and then we'll talk about how things go together. So we'll do two things today with this one. We'll talk about, what actually matters for you at home with home Ethernet. And then we'll also talk just a little bit about some of the specification, but that'll really be kind of minor because we really don't need to know a lot about that for our home networks. So let's get right into it. Now, first of all, when we start talking about our home network, why don't we figure out where our Ethernet part is? And so this represents kind of a very common sort of home network topology. Over here on this side, we have our ISP connection, whoever that is, whatever that is. And then that comes into a modem of some kind. Now, if you have a telco connection, right, if you're just using the telephone pairs, then you have a DSL modem. And if you have coax coming in, then you have a cable modem. And then more recently, we see a lot of homes being outfitted with a fiber connection. And so you'll have a fiber modem of some kind. But on the other side of that, on the inside of your network, you have Ethernet. And so whatever kind of modem you have, that is going to run Ethernet to your internal or home network. Now, the next component, and probably the most common that we see here, is some kind of wireless home gateway. Whatever that is, Linksys, D-Link, whatever, you have a home gateway of some kind. And so sometimes you have a wireless connection to your laptops and things like that, but then you have a wired connection to your PCs or your gaming stations or things like that. So since today we're talking about Ethernet, we're really concerned with our wired connections. And so those will be, the connections to your PCs. By the way, just as a hint, your external connectivity, unless you have fiber, your external connectivity is almost always going to be less than the speed or the capacity of your internal network. So it's very common to be, sort of confronted with the problem of, well, these ports that I have internally on my PCs, my laptops, my home gateway, a lot of times are gig links or gigabit links. And externally, we get something less than that. It's extraordinarily common. In fact, it's the way of the world. Even if you have fiber, you might be very commonly at a half a gig or 500 megabits per second. So when you're doing a speed test, you're not going to get, those gig links that you have internally. Even if you have modern Wi-Fi, and so you're over 100 megabits per second, that's going to be throttled down when you get to the outside. So that's a very typical scenario. But internally, PC to PC or PC to node, printer or something like that, very commonly you're going to be above 100 megabits per second or even into the gigabit range. All right. So today, these red arrows indicate where our wired connections are and then, therefore, where our Ethernet is. Now, 802.11 or Wi-Fi, that represents the other half of our connections to our home network. We're not going to talk about 802.11 today, but I will. We'll talk a lot about its deployment and how you build your home networks, but today we're going to concern ourselves with the wired side or Ethernet. Okay, great. What's Ethernet? You've probably all heard the term, and sometimes we just talk about our wired connection. But what Ethernet really is sort of the superstructure to your network. It is what we encapsulate all of our transmissions in. It is the protocol that runs at what we call layer 2, a very low layer in our network, and it is sometimes called the truck because you put all of your data inside an Ethernet frame, and then you send it across the network. But Ethernet is actually much more than just, the transport mechanism that we use. It has lots and lots of different aspects to its operation, but generally speaking, computers take turns sending traffic to and from the network. So Ethernet, or at least modifications to the early Ethernet standard, offer the mechanisms by which we send stuff across the network, the encapsulation, the addressing that we use, but they also provide speed and duplex negotiation. So are you doing 10 meg, 100 meg, or gigabit per second? Are you doing full duplex versus half duplex? These are all part of Ethernet negotiation. We even today negotiate power over Ethernet. So if you're supporting an access point or voice over IP, or even some other kinds of cameras sometimes get power from Ethernet, so you don't have to plug in a separate power injector or power supply. So those are the 802.3AF or AT standards. Now we also classify cables. So when we get a cable such as this one here, well, we call this a network cable, but it's really, if it's running on an Ethernet network, it's really an Ethernet cable. But turns out that there's a lot more description that we can add to this, and we'll talk a little bit more about that later on. So this is a network cable, but because it's plugged into an Ethernet network, we might call it an Ethernet cable or a patch cable. Now, on the technical side of things, there are multiple standards that describe exactly how Ethernet works, all the way down to its electrical and physical characteristics on up to its operation between nodes. So the main standard is IEEE 802.3, but we can't talk about Ethernet without mentioning Bob Metcalfe and Dix Ethernet, or Digital Intel and Xerox Ethernet. Now today, everything is sort of encapsulated in 802.3, but it's fun to talk about the early generation. Ethernet hails all the way back to the Aloha protocol that ran between the Hawaiian Islands as a wireless communication. And here is the original vision for Ethernet. Of course, today it looks a lot different than this, but this is the famous Ether or the Ethernet connection where nodes tap into a coax connection. And here is the transceiver. Now 802.11 is the other structure for our networks. Now the funny thing about 802.11 is it always goes back to an Ethernet connection of some kind. So even if you're talking about wireless and you really, really dig wireless, your access points connect back to Ethernet. So today we're going to focus on Ethernet, but we'll talk about 802.11 later on. And in fact, I did a whole series on 802.11 that I will link in the show notes. So I mentioned that there were two flavors of Ethernet. There are, in fact, two encapsulation mechanisms that we use. You could argue that there are three that live together on an Ethernet network. So it's very common to see the two of them. So when you're doing a Wireshark capture, and if you haven't gone out and gotten Wireshark yet, go do that right now. Stop watching this video and go get Wireshark right now. The two kinds that you see commonly in Wireshark are Ethernet Type 2, as you can see right here, and this is actually what Ethernet or what Wireshark calls Ethernet, or IEEE 802.3. Now, today we're really 802.3, but the name Ethernet sort of stuck, and so this is why we see the two of them on the networks together. So let's take a quick look at Wireshark and we'll see what I'm talking about. So here is a Wireshark capture. If I grab a spanning tree example here, I can see that Wireshark is telling me, and maybe I'll blow this up a little bit. Wireshark is telling me that this is IEEE 802.3. This is actually the written standard. You can go read it. I'll show you a screenshot of it here in a second. And then we can see what we call the Ethernet header. And we've got a couple of different kinds of addresses here, but here's one of the big differences between Ethernet Type 2 and 802.3, this length field. That's really the only thing that we can see in Wireshark that makes a difference. If these values are below 1536 or 0600 in hexadecimal, then this makes this 802.3, and we use it for a very particular set of purposes. Now, this example is spanning tree, but anything that's not user data is very commonly wrapped up in an 802.3. So we use it for management, things of that sort. If I grab another one here, we can see that this one says Ethernet type 2. Now, Ethernet type 2 is used almost always when we see that we're carrying data. And if we take a look now at this value is a much higher value. Now, this is hexadecimal, but it's going to be above 0600. This one happens to be 0800, and that tells me that I'm carrying IPv4 traffic. And so this is really the only difference that you can see in Wireshark. Now, what does it matter to you? Does it matter what kind of addresses we're seeing on our home networks? No. Does it matter whether or not you're doing Ethernet type 2 or 802.3 if you're just interested in standing your network up and getting it working? No, it does not. But if you're working on an Ethernet network and you're concerned about security or optimization or troubleshooting, these are going to be part of the things that you look at. But for our home networks, we're really not too big on these kinds of things. But that's why you see the differences that you do in Wireshark. And as promised, this is the IEEE 802.3 standard. You can actually go out and read this. It's just a document, but it describes everything. And this one here is just part of the standards that apply to Ethernet. You can see that it is hundreds and hundreds and hundreds of pages long, and it describes all the things that we're doing on Ethernet. Now, there are a bunch of related standards. I mentioned Power over Ethernet, 802.3 AF, AT, but they're all based on this 802.3, or they're designed to work in conjunction with 802.3. So, what do we really care about on our home networks? Well, as I said earlier, you're going to get a cable like this. So anytime you have cabling, this is really one of those things that can have a big impact on your home network. Now, there's a couple ways to think about cabling. One is the category. The higher the number, the better the cabling is, and the more data you can push through that cable. But there's two other really, really important characteristics that we want to look at. The cable that I keep waving around here, this is unshielded twisted pair. And what that means is that the individual pairs are twisted. Now, the cable that we use in networking has 4 pairs, and each one of them is twisted. But not only that, they're twisted at a different rate. The twisting reduces the electromagnetic interference and the crosstalk that we get. But if we look at a little harder at the individual conductors that are inside this cable, sometimes they're solid copper and sometimes they're stranded. You see the little copper hairs here. And that makes a huge difference. Stranding the copper makes it so that you can do crazy things like this. You can send this cable anywhere, you can twist it around things. It's very, very easy and flexible to work with. But it increases the attenuation of signals. So we don't want to have cables like this used in any long distance. So that means if you were installing cable in your house, you want to make sure that your jacks are going to be using solid copper or solid core cabling. Do not use long runs of stranded cable because you won't get the performance out of your network that you think you ought to. You want to make sure that your wall cable, or what we call your plenum cable or your home run cables, these are solid copper. And if you are building your own network, make sure that you put in the highest category that you can get away with. Category 6 is the sort of standard today. So in new installations, we're looking at Cat 6, maybe even Cat 7. But there we go. Solid copper versus stranded copper, and then your category. Now, if we talk a little bit more about the cables, another idea here is that in addition to the twisting and the solid core versus stranded, we also want to understand that there's a couple of different kinds of cables as far as their construction goes. So this cable, right, this blue one is straight through. Now, if I take a look at this, I'm going to put it up to the camera. You won't be able to see it, but maybe we can if I zoom way in here. So if you were to look at what the colors are, right? If we could see that maybe, you can see that pin 1 goes to pin 1. And so on. Pin 2 goes to pin 2, pin 3 goes to pin 3. And when we do that, what we're doing is we're saying, I'm going to terminate one side with 568B, EIA 568B. This is one of the cabling standards we have. If the other end is also terminated with EIA, or Electronic Industries Association 568B, we have what we call a straight-through cable. If, however, we start one side with EIA 568B and we terminate the other end with 568A, we have what we call a crossover cable, and that's this one right here. And a crossover cable is there to send the green to the normal orange spot and the orange spot to the normal green spot. What does that do? Well, that crosses transmit to receive and receive to transmit, so that I can hook nodes directly to each other. We do this in between networking devices sometimes and in between PCs. Now today, the reality is that devices auto-sense this, but we don't want to use crossover cables where we shouldn't be using crossover cables. Now, it's very common to have crossover cables as red cables, and that is a very clear indication that this happens to be a crossover cable. If you have older gear or older network interface cards, you might be forced to use the correct kind of cable because it doesn't auto-detect. I'll try it again on this, but if you look at this particular pinout, put that in front of the camera maybe, the colors do not go straight through. Pins 1 and 3 go to pins 2 and 6, and vice versa. Now, at the top of this slide, it also says RJ45. What in the world is an RJ45? Well, this jack is an RJ45 jack. It's an RJ45 male jack, and this is an RJ45 female. Here's another style that we use, but these are both RJ45s. RJ45s are the ones that we use for data. Now, there are other jacks out there. An RJ11 is a much smaller version, and if you look at your telephone cords, they have RJ11s on the end of them. Oops, RJ11s. Now, what's the difference? Well, RJ45 is 8-pin and much larger. Now, if you look at these pins, what's the deal with all these colors here? Well, the orange and green pairs, that's what Ethernet uses. But we have two other pairs. Well, the blue pair is the RJ11 pins or the telco pins. This is why when you go into a telco closet and you see all this blue wiring around, that's all for the telephones. Now, the interesting part about it is that the RJ11 goes right into the RJ45. There we go. And so what this means is that in modern infrastructure, you do not have to use separate or build separate wiring plants or cable plants for telco versus your data. The telco can use the exact same infrastructure and use the same jacks. So you can plug in your telephone lines to your data lines. And what happens is the tip and ring pair that we use for the telephones goes right smack dab in the middle of the RJ45. And that's why this pair is dedicated or reserved for the telco. So if you look at a telephone cable, you'll see that the telephone cables, that's your red and green. We call those tip and ring, and goes right in the middle of the RJ45. Now, 7 and 8, the brown pair here, that is what we use for power over Ethernet. So now we're using all of our cables. So the green and orange pairs, that's for our data. Blue is for telco, and then brown is for power over Ethernet. So whether you're using 802.3 AF or AT, that's where it's going to run. So straight through cables, crossover cables, and then what are all the pins used for? Okay, let's talk about expanding our network a little bit. Now, if we just have a wireless home gateway and we find out that it's not enough, the wireless signal doesn't cover what we want, I don't have enough jacks to go around, this is what you do. If you upgraded, so you have one of these other wireless home gateways sitting around, then you can actually plug them directly into each other. Wait, can I really do that? Yes. So here's what you would do. So we're going to go a little bit bigger screen for our demo time here, but here's an example of, right, this is just a link sys, right? And we can see that on the back of this, I have a number of ports. Some of them are Ethernet ports, and one of them right here is labeled Internet. So this is kind of like the one that you normally see, right? It's got the antennas. Sometimes you have two, sometimes you have three, sometimes you have four. Here is another example of a wireless home gateway. This one is a Belkin. It has Ethernet ports on the back of it too, and it also has my internet port, but no external antennas. The antennas on this one are inside. So how would I take these two devices and hook them together? Well, it's very straightforward. I would simply take my Ethernet cable. Now this is where you could use a crossover or a straight through if it auto senses. And I would take one of my Ethernet ports and I would plug that right into the Ethernet port. And then I would take this one and plug it also into an Ethernet port. Now the two devices are connected together just like I showed in the topology. Now, if this is the downstream device, what I want to make sure that I do is turn off DHCP and I don't use the internet port. I don't want to do that. What I'm doing is connecting my layer 2 network, my layer 2 Ethernet network, to the other Ethernet network. And I don't want to turn on services on this device. And what this allows me to do is expand my network and cover a much wider ground, but it also increases the number of ports that I have for other devices. So how would you get one of these things? Well, I've collected a whole bunch of these things just going to garage sales. People throw these things out all the time. It's a very easy way to get a collection of cables, but also collect devices that might allow you to expand your network. They might not perform as the latest and greatest devices, but in a quick fix sort of thing, or to just expand your network a little bit, especially if you're talking about expanding your wired ports, yeah, go ahead and use them. And this brings me to another way to expand our network. Take a look here. What I've done in this case is replace that other wireless home gateway with a simple Netgear switch. These are very inexpensive devices. They actually perform very, very well for what you pay for them. And this is another one of those garage sale finds that you might have. The collection of cables that I have in my place is largely due to my going to garage sales and picking out the network cables that I want, and sometimes the networking devices that folks are getting rid of. Remember that even if this is a 100 meg switch, so it's an older switch, your outside connection to your ISP is not going to be 100 meg anyway, unless you have fiber. And so it's a perfect addition to your home. But sometimes you get lucky and you find somebody that's getting rid of a gig switch. So there you go. All right, so this has been a discussion of home network Ethernet. Remember that it is the wired stuff that we're talking about. We'll talk about the wireless stuff later on. Some details can be ignored. It's not really important that you have an in-depth understanding of the Ethernet standard or the address types or how Ethernet uses carrier sense multiple access with collision detection. But some things are kind of important. The quality of your copper that you put in, the quality of the cabling that you put in. Don't use stranded cable for your infrastructure. Only use patch cables or stranded Ethernet for short connections to your individual devices. If you're going to install or you're going to buy something, buy Cat 6. And remember that you can easily and sometimes very inexpensively expand your network. You don't need to buy the $200 wireless home gateway. Sometimes we want to do that, but a lot of times they're selling features that we might not be able to use. Remember that if you put in a brand new access point with 1,000,000 antennas on it, you might not have nodes that can make use of that wireless infrastructure. So you find something in a garage sale and it actually works, go ahead and put it in and see if it does the job that you need it to do. Well, there we go. That'll do it for home network Ethernet. Thanks for watching. Like and subscribe if I helped, and may those packets cruising across your home network always reach their destination.